For this second section, we're going to be looking at what it means to be, so this is 1.2 or 1-2, and we're going to talk about how we figure out parts of a fraction or um, how that works. So if I have 6 fraction bar 2, we can simplify this to 3 over 1 or just 3. And the way this works is you take this bottom number and you divide it into the top number. So it's always denominator, which is the bottom, divided into the numerator to figure out your answer. So I would have 2. So for those of you that haven't done long division in a long time, you'll figure this out hopefully pretty quick. So 2 divided by 6, or 2 times what equals 6? Turns out the answer is 3. Then you come back and you multiply these two. You put the answer down there, and then you subtract them. Or you do the opposite of, as we talked about in the last section, you do the opposite of the 6, which is negative 6, and you get 0 here. So that's where, and then this is your answer. So let's talk about like just looking in fraction form. Let's say that we have 1/3, and what does that look like as a decimal? Well, you take the 3, and which is the denominator, and you divide it into the 1, which is the numerator. And one thing that I want to point out is that 1 is the same thing as 1.0 or 1.00. As long as the number in front of the decimal is the same as this whole number out here, then we're good to go. Okay? So I'm going to do 3 divided by 1, knowing that I can add zeros. So 3 into 1, that doesn't even go in one time. So we're going to have to add some zeros out here to figure out. Now the decimal point goes straight up. It's straight above where it is inside that fraction bar. So now we do 3 into 10. Well, if we count by threes, 3, 6, 9, 3 of them. If I go one more, then I'm at 12, which is too much. So this is going to be 3. And then I'm going to multiply these two. That's 9. Then I'm going to do the opposite of 9. And I'm not going to pay attention to the decimal here because I already put it up there. So this is really just 10 minus 9, which is 1. Well, if I've got a remainder down here, a number left over, so if it didn't turn out to be 0 like it did over here, then I'm going to have to add another 0. And I'm going to switch colors for this. Let's make that red. So now we're going to do this. We're going to bring this one down. And we have the same thing, 3 into 10. Well, it was 3 before, so it's going to be 3 again. And 3 times 3 is 9. Opposite of that. And so this will be 1. Now I'm going to switch colors again. And I'm going to add another 0 because this number wasn't 0. And I'm going to bring this green 0 down here. And we're going to do 3 into 10 again, which is 3. 3 times 3 is 9. Do the opposite of that, we get 1. And you can see that we've kind of established a pattern here where these numbers are just going to continue to be 3s, and we can keep going on forever. And so 1/3 is equal to 0.3. It's also equal to 0.33. It's also equal to 0.33. It's also equal to 0.3333. And when it repeats like this, to indicate that it's going to be repeating, we put a line over the part that repeats. Since it's the 3 that's repeating, we go to the last 3 that we listed, and we put a line over that. And so you could just say 1/3 equals 0.3 with that bar over it showing that it's going to keep repeating. Now, if we have a number like 5/8, which is going to be similar, I'm going to go back to the black over here. And so again, this number goes on the outside of the division sign. This number goes on the inside. So we're going to have 8 division bar 5. Since the 8 is bigger than the 5, we know that we have to add a 0. And we're going to bring this decimal right up above there so we don't have to pay any attention to it. So how many times does 8 go into 52? Well, 8 times 4 is 32. 8 times 5 is 40. 8 times 6 is 48. So that's pretty close to 50. If I go 8 times 7, that's going to get me over the 50. So we want to stay below. So we're going to say that this is 6 times. And then 8 times 6 is 48. We're going to do the opposite of that. So 50 minus 48 is 2. Well, that wasn't a 0, which it needs to be if we're going to. So now we're going to add another 0. We change colors. We're going to add this 0. And we're going to bring that down here. Well, now it's different how the 1/3 was. The 1/3 just kept giving us a 1. We don't have a 5 like we had before. Now we've got a 2. So 8 goes into 20 2 times. 2 times 8 is 16. Opposite of that. 20 minus 16 is 4. Okay? Change colors. And I'm going to add another 0. Actually, I'm going to extend this bar so we make sure that we get everything underneath the fraction bar. Add another 0. Bring that one down here. And each time you figure out how many times it goes in, make sure that you put it above the last number in the number that you use. So on the first one, we used the 50. So I put the 6 above the 0. The next one went in twice, so we put that above the next. So whatever number I get here, I'm going to put above the blue 0 so that you keep things organized. 8 into 40, well, that's 5 times. 5 times 8 is 40. And do the opposite, and so we get 0. We finally got to the point where it was 0. So this one, 5/8, is equal to 0.625. Could you put a 0 in front of this? Yes, you could. It's not really going to change the value any. Just like these zeros after didn't. If you put a 0 before, it's not going to change the value any. So, but this one we're not going to put a line over it because of the fact that we got to the point of a 0. So 0.625 is equal to 5/8. Now, what if we had like 3 divided by 1? Kind of the inverse or the flipped over version of the 1/3. If we have that, we're going to do the same thing. 1 into 3. How many times does 1 go into 3? It goes in 3 times. 3 times 1 is 3. Do the opposite of that. We get 0. So we got to the point of having 0 down here. And so 3/1 is equal to 3. This number right here is considered a whole number, or you could also consider it to be an integer. Integers could also be, as we talked about in the last slide, the absolute value of negative 3, would be positive 3. The absolute value of positive 3 would be 3. These numbers are all integers. So negative 3, negative 6, basically whole numbers that are positive or negative numbers. And then the last thing that we want to talk about is our rational numbers. Well, what is a rational number? A rational number is anything that could be written as a fraction. So for example, 1/3, 1 divided by 3 is, I was able to write that as a fraction. So that means that 0.333 repeating is also a rational number. Now, in order to be a rational number, it either needs to be a whole number or an integer or be able to be written as a fraction. And if it's written as a fraction, it's either going to be have a repeating like this, or it's going to be how we had with the 5/8, where it just stopped. So it's either going to end or it's going to be repeating the same value if it's a fraction. So the number like pi, we know that it starts out at 3.1415, which those don't repeat. In fact, it never repeats. It just keeps on dividing out forever. I think that the last number I heard was that somebody had calculated, or a computer had calculated it to 3 million, or an extremely large number of places after the decimal. And so we just know that numbers like pi, which will never end, are not rational numbers. Okay, so we're going to stop there. Make sure that you go into your assignments and find the practice problems for 1.2. And so that will be your second assignment for this week and the final assignment before your stuff is due. Well, actually, I take that back. We're going to have a quiz, but we'll meet in class before then.